All right, so this is the third presentation for Unit 1, and this one's just really going over basically Earth science. So this is all science. This should all be reviewed from middle school and even some from elementary, so it shouldn't be too difficult. So first off, obviously the Earth is the only planet in the solar system that has at least advanced life. Not the only one with water anymore. We found water on some other planets, but of course, this is the only one with sustainable life, and also, of course, the Earth is made up
Hi,
of.
Major
Well, we got some
Archie
announcements.
teachers. 9300 hallway. Hold off on coming down for pictures. We'll call you down in about 5 to 10 minutes. 9300 hallway. Do not come for pictures until called. Thank you.
All right, so the continents, of course, they shift and move around on the Earth, and then, of course, you should know that we are the third planet from the Sun. Not going to spend any time on that. And then the layers of the Earth, you don't have to know all the layers, just know that, of course, there are layers to the Earth. You should know at least that the top layer we live on is the crust, which is the thinnest layer. And then you do need to know your spheres. So the atmosphere is the layer of gases that surround the Earth, so like oxygen and stuff like that. Lithosphere is the solid rock portion of the Earth, so that's basically the crust. The hydrosphere is all the water elements, so that includes the ocean, all the oceans, icebergs, glaciers, lakes, ponds, groundwater, everything. So all water is part of the hydrosphere. Then the biosphere is where plants and animals live, which of course is in the ground, on the ground, and in the air if you're a bird. And then you should know the idea of the continental drift theory. It's called a theory, even though we pretty much know it happened. But originally, all the continents were together in what was called Pangea. You do need to know that term Pangea. So that's when all the Earth was united together, as you can see in the diagram, and then it drifted apart over time to where we are today. The only continent that hasn't really moved a whole lot is Africa. You can say Antarctica as well, but mainly Africa has stayed pretty centrally located. All right, getting to bodies of water and landforms. Of course, most of the Earth is water. 71% of the Earth is ocean. And then you should know the water cycle. And if you need a review on that, just watch Magic School Bus. They have an awesome episode about the water cycle. But the term you need to know for the water cycle is the hydrologic cycle. So basically, water evaporates, it rains, it goes back down into rivers and underground water and back into the ocean, and then evaporates again, and so on and so forth. Now, of course, that cycle can take years and years and years for water to actually go through that. Then, of course, obviously, water goes from high ground to low ground. So you need to know what a drainage basin is. So here on this little map down here, you can see the Mississippi River drainage basin. So all of the water in this part of the United States eventually flows into the Mississippi River at some point and then out into the Gulf of Mexico. So all the land is basically sloped in this direction downward towards the Gulf. Hence why it's so easy to flood in Louisiana. All right, so here it is again, drainage basin. So where all the tributaries kind of feed into, and of course, a tributary is like a branch of a river. So think of the river as the trunk, a tributary is a branch that runs into the trunk. Groundwater is obviously in the ground. It's where you get to the point in the water table to where you can get an aquifer, so it becomes so saturated you hit the water table. So for example, here, if you lived outside of town and you had well water, you would have to drill about 800 feet down before you hit the water table, and you just get to water, and you can use that to drink. All right, and then here's just drainage basins around the world. You don't really have to know these. It's just trying to show you there. All right, and then different landforms. If you have the textbook, you can look at it. But other than that, really the vocabulary I gave you, the words that are already done for you, is pretty much all the landforms you need to know. And then you should know what the continental shelf is. And so as the continent goes into the ocean, as you can see in this diagram, usually it just slowly slopes into the ocean, and then at some point, usually half a mile or mile out, it just drops down into deep ocean. So this area is called the continental shelf. So it's the area in the ocean, the shallow area as it leads up to the continent. All right, and then a relief. This is a relief map, which is basically a topographic map. So this is a relief map of China. So it shows you the elevation. As you can see, it's higher in elevation over here where the Tibetan Plateau is. And then most of the people live here in the lower areas. So it shows you the different landforms, based on this map. So you should be able to look at this, if I ask you a question, based on this relief map of China, where would you assume most of the population lives? Especially if it didn't have the cities on here. Obviously, it's going to be in the lower elevations, especially near the coast and along rivers, because they need the water, of course, for farming and things like that. It's easier to farm and trade and move around in flatter areas and lower elevation. All right, internal forces. All right, some things happening in the Earth. All right, so convection inside the lithosphere. So you should have learned convection, I'm sure, in science class. So in this case, we're talking about within the lithosphere. As that occurs, obviously it causes the tectonic plates to move around, and these are the large tectonic plates. Now there are fault lines within these, so it's not like that's it. There are fault lines all within these different plates, but these are the large plates that are moving around the Earth. So here you can see the directions they're going. So North American plate, we're sliding towards Asia. Asia's coming towards us. So a long, long time from now, we'll hit China. Africa is pushing its way back up into Asia and Europe a little bit. So we're getting further away from Europe, basically, and Africa. All right, you need to know these three different types of plate boundaries and what occurs on each one. So a divergent boundary means they're spreading apart. So in case where plates are spreading apart, you're not really going to see any earthquakes. What you will see is rift valleys. It's like in Eastern Africa. We'll talk about it when we get to Africa. But over here, Somalia basically is spreading off and breaking away from the rest of Africa. So it creates these big rift valleys in between. And then convergent boundaries is where the plates are colliding and hitting each other. And that causes mountain ranges to grow. So in this case, you may see subduction, which is where one plate slides underneath the other plate. And this can push magma up to the surface and then create volcanoes. And then a transform boundary is where plates are sliding past each other. So, like if you take your knuckles and like kind of push them up against each other and create more and more pressure, eventually it'll break. And that's basically what is happening at a transform boundary, like what we saw in Italy. All right, so here's just a diagram for it if you need to look at it and kind of get a better idea. So again, subduction to where it's pushing the magma up and create volcanoes and stuff like that. So if you need to look at that, you can pause it. All right, and then other terms, fracture in the Earth's crust, of course, is a fault. You should know what an earthquake is. And then another key term is the epicenter. See if I can highlight it. Well, my computer wasn't stinking slow. Whatever, there you can see it. All right, so the center of an earthquake is the epicenter. So the epicenter, of course, is where the earthquake originates from. It's within the crust itself. As far as how deep in the crust it may be, can vary quite a bit. The closer it is to the surface, the more the earthquake is going to cause damage. Then the seismograph is the device that we use to measure the strength of an earthquake, and then the Richter scale is what we rate them on. So generally 7 or higher are horrible earthquakes. Of course, what we saw in Italy was about a 6.2. So even though it's below a 7, it was still very damaging because the epicenter was closer to the surface of the crust. And then here, of course, you can see the San Andreas fault there, fault line. All right, and then you should know what tsunami is as well. So if earthquakes occur in the ocean, sometimes you can see a tsunami. A tsunami travels around 450 miles per hour and get up to a height of 100 feet. Really, the difference between a wave and a tsunami is that a wave is just surface level. It's just the surface of the water moving, whereas a tsunami is the column of water moving. So the entire column of water from the ocean floor all the way to the surface moving together. And then, of course, as the ocean floor comes up, as you come up to the continent, then that column just starts coming out, going up and up and up above the ocean, and then we'll hit inland. So they can go a couple of miles inland just depending on the size of the tsunami and kill a lot of people. These photos are from one in Alaska. Of course, really the deadliest one was 2004. Killed over 200,000 people in Thailand, in Sumatra, in that area, after a very large earthquake hit there. And then you should know what the Ring of Fire is. Again, I'm sure you've learned this already. So this is where we see most of our earthquakes and volcanic activity is along this region surrounding the Pacific Rim is another term we'll use for that. All right, external forces, this last section. All right, so weathering. So this is just the process of rocks breaking down, basically. You need to know, what causes weathering and erosion. All right, so first off, you get mechanical weathering. So this is like frost, plant roots, things like that can change the size of rocks. Of course, frost gets into the pores of rocks, and when it freezes, it expands and causes the rocks to break over time. And then chemical weathering, this is going to be things like rust, so like oxidization when it gets on your car, over time when your paint chips off, it begins to rust because of the oxygen in the air. And then, of course, again, you should know what erosion is. Come from wind, water, ice, and of course, there's gravity. So water erosion you see mainly along rivers and streams. It carries sediment downstream. And then sediment is, of course, what is left behind. So like as the Nile flows towards the Mediterranean, it's going to leave sediment all throughout here along the delta. And of course, the delta is where the river fans out as it gets close to exiting into the ocean. So here the Nile fans out in many different directions. And this is what allowed people in Egypt to even live there, is the fact that there was a delta. And then, of course, deposition is when that sediment is collected in different areas. That's deposition. All right, then wind erosion obviously picks up dust, creates dust storms like the Dust Bowl back in the 1930s. A lot of loose sand at the surface levels caused all of the sand to be picked up and carried very far away. And it can go really long ways. Like we get sand from the Sahara Desert in North Texas. Goes all the way across the ocean over to here. And then glaciers, as they move, obviously they break down rock. You need to know the term for that. It's actually not on here, but the term for that is glaciation. So glaciation is when a glacier breaks down and erodes the area as it slides down. And then you don't really use the word moraine much. Of course, you should know what soil is and stuff like that. And that's really it. So, I mean, it's just basic review pretty much of middle school and probably some elementary on that one. So that's it for this section.